Have you ever started the project that was moving fast only to see its growth completely stall? Does adding one feature somehow introduce 10 new bugs? Or do you feel trapped by old libraries and databases making updates seems impossible? You are facing architectural friction. But there is a solution called clean architecture. Stick around with me and I will show you how writing software using the clean architecture can save you countless headaches in the future and help you build software that lasts. Welcome back to my channel. My name is Vikas and today we are diving into one of the most popular and powerful software architecture called clean architecture. This architecture is introduced by the legendary Robert C. Morton, often called Uncle Bob, back in 2012. Just like any good software architecture, the goal of the clean architecture is to minimize the human resource required to build and maintain the system. It is very important to make sure that the foundation of your software is solid. If it is not solid, you can't guarantee the quality of the software you are building on top of it. Clean architecture gives you that solid foundation, emphasizing the separation of concern, scalability, and maintainability. Let's explore what the clean architecture is and why it matters. Clean architecture combines several smart design principles. Understanding these rules is key to applying the structure correctly. Rule 1 is a separation of concern. This means organizing your code into independent layers where each layer is responsible for only a specific part of the application. For example, the domain layer can define all the business logic, an application layer can have all the use cases and application logic, and the infrastructure layer can have UI or databases. This ensures that the core business logic remains independent of technical details and external frameworks, leading to more maintainable, testable, and flexible software. By separating these concerns, developers can focus on one aspect at a time and manage changes more effectively. The second rule is the single responsibility principle. Every module, class, or function should have only one job and only one reason to change. This makes your software easier to implement and prevents unexpected side effects when you make future updates. Next, we have open-close principle, also called stability rule. This rule states that your code should be open for extension but closed for modification. If business requirements change, you shouldn't alter the existing working code. Instead, you should add new code that extends the old code. This keeps your system stable because you are not changing any existing code at all. In clean architecture, this is achieved through abstractions like interfaces or abstract classes, allowing you to add new implementations or adapters without altering the original stable code. Next, we have dependency inversion principle. This rule is the foundation of how the layers interact. Your core business logic should not depend on external layers like specific database or framework. In other words, your domain layer should not depend on the application layer, and the application layer should not depend on the infrastructure layer. Instead, the dependencies flow inwards. We define abstractions like interfaces in the core, and the outside world implements those interfaces. Clean architecture divides your code into distinct layers, making your code highly maintainable and testable because we can develop each layer independently. Let's understand these layers one by one. The innermost layer is a domain layer where all the core business rules are available. This layer is the backbone of clean architecture and it represents the core use case independent business logic of system domain. This layer is highly abstracted and stable and it should not have any dependency on any external library or frameworks. All the other projects available in the outer layers should depend on this domain layer. Usually, this layer contains your domain entities, your aggregates, value objects, domain events, enumerations, constants, and more. Next, we have application layer. This layer implements the business logic and the use cases of your application. It is dependent on the domain layer, but it has no dependency on the infrastructure or presentation layers. Mostly, it defines interfaces that are implemented by the outer layers of the clean architecture. This layer contains abstractions, contracts, ports, interfaces, business services, CQRS commands and queries, application exceptions, DTOs, request and response models, domain entities to DTO mappers, validators, behaviors, and specifications. Next, we have infrastructure layer. This layer handles the rest of the external details and implementations of the interfaces defined in the application layer. This is the place where you connect to third-party services, handle things like logging, authentication, or file storage. This layer contains authentication and identity services, file or object storage, message queue storage, third-party services, email and notification services, logging services, payment services, social logins, and so on. The next layer is persistence layer. This layer focuses purely on databases and caching operations. It takes the interfaces defined in the application layer and implements them using the specific tools like Entity Framework or Dapper. This layer also contains dependencies related to specific databases such as SQL Server or Oracle. Usually, this layer contains data context, repositories, data migrations, data seeding code, in-memory caching, or distributed caching. Finally, we have the presentation layer. This layer is normally responsible for presenting some graphical user interface or exposing some public web APIs. This layer contains web pages, web components, web APIs, controllers, views, middlewares, filters, attributes, view models, style sheets, JavaScript file, images, and so on. Clean architecture is a very powerful software architecture, but it's not without some of its challenges. First, there is a learning curve. If you and your team are used to old architectures, it takes proper learning to understand how to split the responsibilities between different layers. Secondly, there is complexity. It requires significant upfront design work to separate the concerns correctly. There is also a risk of over-engineering, so balancing the simplicity with abstraction is a key. Finally, there are some tools limitations. Some development tools, especially the object relational mappers, tightly couple the data access layer with the domain model, making separation difficult. If you are building a new greenfield application, or if you have a big and complex application with lots of unique business logic, then the clean architecture is worth considering because it helps you build testable, maintainable, and scalable applications. If you want to start learning by doing, I highly recommend checking out the sample projects and open source templates listed in the description of this video. You can find examples for .NET, Node.js, Angular, React, and more. If this video helped you understand the clean architecture, let me know in the comments below. And don't forget to like this video and subscribe to my channel for more software architecture videos. Thanks for watching, and until next time, stay awesome.